human hand is one of the most important tools in our daily lives. It allows us to work, create, and interact with the world. However, in many industries such as manufacturing and construction, workers face a high risk of serious hand injuries. For people who lose their hands, the challenge is not only physical, but also psychological, bringing stress and difficulty to daily life. Existing robotic hands or prosthetics are often very expensive, making them difficult to access for most people. This project addresses these challenges by developing a low-cost robotic hand, controlled by voice, to mimic human gestures and provide basic grasping ability. The main objective of this project is to develop a functional robotic hand. The first goal is to build a robotic hand using an ESP32 as the main controller, so that it is both low-cost and efficient. The second goal is to design the robotic hand to perform 10 common gestures, which can be used in games or in daily life, such as okay, good, which represent basic movements of a human hand. And finally, the third goal is to evaluate how effective the robotic hand is in real tests, such as gesture demonstrations and grasping objects. In order to achieve these goals, the system was carefully designed. The system design is divided into 3 parts. First, the control system, built with ESP32 and Arduino Nano, processes voice commands and drives the servo motors. Second, the power supply, which provides a stable 5 volts and up to 8 amperes for the system. Finally, the input and output system, where the force sensors act as input and the servo motors serve as output to perform gestures. So from these components, the robotic hand delivers 4 main features. Voice control allows the hand to respond directly to spoken commands. Force sensors provide grip feedback through the thumb, index finger, and middle finger. Object stability ensures the hand can securely grasp cylindrical and spherical objects between 2 to 6 centimeters in diameter and weighing around 100 to 200 grams. And finally, common gestures, where the hand can perform 10 familiar human gestures such as numbers, okay, good, and rock, paper, scissors. As one of the main outcomes of this project, the robotic hand is able to successfully perform multiple gestures. Specifically, it can demonstrate 10 common gestures, including rock, scissors, paper, the numbers 1, 3, 4, a rest position, and symbolic gestures such as thumbs up, okay, and finger gun. Grasping objects is one of the most important functions of the human hand in daily life. To reflect this, the robotic hand in this project also aims to perform basic grasping tasks. Subsequently, the robotic hand can grasp objects with specific shapes and dimensions. In particular, cylindrical or spherical items with a diameter between 2 to 6 centimeters and weighing around 100 to 200 grams can be held more stably. Another key outcome of this project is that the robotic hand can be controlled by voice commands. Using the voice recognition module MIV3, the system is trained with 18 different commands. These include basic actions such as open hand, close hand, and gestures like 1, 3, and 5. On average, the system responds within about 1 second. The success rate of recognition ranges from around 45% to 90%, depending on the command and the user's voice. In conclusion, this project has successfully achieved its 3 main objectives. First, a low-cost robotic hand was developed using the ESP32 as the main controller, supported by additional microcontrollers and sensors. Second, the robotic hand was designed to perform 10 common gestures, including numerical signs such as 1, 3, and 5, and symbolic gestures like good, okay, rock, and scissors. These gestures demonstrate the ability of the system to mimic human hand movements in a meaningful way. Third, the effectiveness of the robotic hand was evaluated through gesture demonstrations and grasping tests. The results show that the hand can grasp cylindrical or spherical objects with diameters of 2 to 6 centimeters and weights between 100 and 200 grams more stably. Beyond the technical outcomes, this project also contributes to the United Nations Sustainable Development Goals. It supports SDG 3, good health and well-being, by showing potential applications for affordable assistive devices that can improve the quality of life for people with disabilities. It also aligns with SDG 10, reduced inequalities, by demonstrating that low-cost solutions can make robotic technology more accessible to those who need it most. Overall, this project proves that a low-cost, voice-controlled robotic hand can effectively mimic basic human hand gestures and grasp objects, providing a foundation for future improvements and wider applications.